A single American carrier strike group represents approximately $30 billion in military assets. It carries more air power than most nations possess in their entire air force. For 70 years, these floating fortresses have served as the cornerstone of American military dominance, the ultimate expression of power projection, capable of influencing events thousands of miles from home waters. Yet in April 2024, when tensions escalated sharply in the Persian Gulf, U.S. military planners confronted an uncomfortable reality. Positioning a carrier within effective striking distance of Iranian targets meant placing it within range of weapons systems that cost a fraction of the carrier's value but could potentially sink it. Iran doesn't operate a single aircraft carrier. They don't need to. They've built something more strategically valuable, an operational environment where the risk-reward calculation of deploying America's most powerful conventional asset has become unacceptable. This isn't theoretical speculation. War games have repeatedly demonstrated carrier vulnerability in Persian Gulf scenarios. Strategic assessments reflect the same conclusion. Operational planning increasingly avoids placing carriers inside the Gulf entirely. The central paradox is profound. The most powerful naval capability ever, created refined over decades, can be effectively neutralized by asymmetric systems developed by a regional power operating on a comparatively minimal budget. And the implications extend far beyond Iran. If a regional adversary can create this problem, what does it mean for carrier operations against peer competitors like China in the Taiwan Strait or the South China Sea? What Iran has built isn't just a regional defense system. It's a blueprint for neutralizing the most expensive military capability in human history, and that blueprint is already being copied. Iran's anti-access area denial architecture rests on 6 overlapping systems, each designed to exploit specific vulnerabilities in carrier strike group operations. First, anti-ship ballistic missiles. The College Fars and Hormuz to provide Iran the ability to strike moving naval targets at ranges exceeding 300 kilometers. This forces American carriers to operate far outside the Persian Gulf itself, significantly reducing their operational effectiveness while remaining beyond engagement zones. Second, swarm tactics. The Islamic Revolutionary Guard Corps' Navy operates hundreds of fast attack craft armed with anti-ship missiles and torpedoes. These vessels aren't designed to win conventional engagements. They're built to overwhelm defensive systems through numerical superiority and dispersed attack vectors that stretch carrier group defenses beyond sustainable response capacity. Third, coastal defense cruise missiles positioned along the northern Gulf coastline, creating overlapping engagement zones across strategic waterways. Fourth, one of the world's largest naval mine inventories, including sophisticated rocket-propelled rising mines capable of selectively targeting high-value vessels. Fifth, an expanding fleet of drones and unmanned surface vessels that provide persistent surveillance and additional strike capability. Sixth, integrated air defense systems threatening carrier aircraft even when launched from standoff distances. Geography amplifies every advantage. The Persian Gulf measures roughly 200 miles at its widest point. Carriers operating inside face constrained maneuver space and predictable positioning. The Strait of Hormuz choke point compounds this vulnerability. Any carrier entering or exiting must transit concentrated threat zones with limited room for evasive action. This matters beyond military balancing. Carriers aren't simply weapons platforms. They're diplomatic instruments that signal commitment, deter aggression, and reassure allies. When carriers cannot operate in contested environments without prohibitive risk, their deterrent value erodes. Israel, Saudi Arabia, the UAE, and other regional partners depend on the credible prospect of American carrier-based intervention. In the Pacific, Taiwan, South Korea, and Japan rely on identical assumptions. If that credibility diminishes, alliance structures weaken and adversaries gain expanded freedom of action. This isn't hypothetical. Future capability. These systems are deployed, operationally tested, and demonstrated regularly in exercises. Recent American force posture adjustments suggest operational planning already incorporates these limitations. These capabilities didn't appear overnight. Iran spent 3 decades studying American carrier operations, identifying vulnerabilities, and systematically building countermeasures to exploit them. The foundation of Iran's anti-carrier strategy was laid in a single day of brutal clarity. Operation Praying Mantis, April 1988. U.S. naval forces destroyed Iranian oil platforms and sank or severely damaged Iranian naval vessels in response to mine incidents during the Iran-Iraq War. The engagement lasted hours. American conventional superiority was absolute. Iran's navy proved incapable of meaningful resistance. Tehran absorbed the lesson. Competing symmetrically with the US Navy was futile. The response wasn't capitulation, it was strategic adaptation. Iran pivoted toward asymmetric capabilities designed to impose unacceptable costs without requiring equivalent platforms. The 1990s brought observation and study. Iran watched carriers dominate during the Gulf War in 1991, where carrier-based airstrikes contributed decisively to coalition superiority. Throughout the decade, Tehran observed continuous American carrier operations enforcing no-fly zones and conducting strikes across Iraq. Flight patterns became predictable. Operating areas became familiar. Logistical constraints became apparent. Iran's strategic community began systematically studying carrier vulnerabilities, the concentration of immense value in a single platform, the predictability of flight operations, the dependence on specific geographic positioning for effective air operations, the defensive challenges of protecting high-value assets in confined waters. The critical development period ran from 2000 to 2010. Iran invested heavily in acquiring and reverse engineering anti-ship missile technology primarily from China and North Korea. Indigenous production began. Coastal defense networks expanded. But the real validation came from an unexpected source. Millennium Challenge 2002. This major U.S. military war game assigned Lieutenant General Paul Van Riper to command the Iranian analog force. In the exercise's opening phase, Van Riper employed swarm tactics and asymmetric strategies to hypothetically sink multiple American ships, including a carrier. The exercise was controversially reset, and critics questioned certain assumptions. But for Iran, the outcome validated their strategic direction. Concentrated forces create concentrated vulnerabilities. 4 years later, another data point emerged from the Lebanon War. Hezbollah, an Iranian proxy, successfully struck the Israeli corvette INS Hanit with a Chinese-designed C-802 anti-ship cruise missile, damaging the vessel and killing 4 sailors. The engagement demonstrated that precision anti-ship weapons could be effectively employed even by non-state actors. Iran's investment in coastal defense, cruise missiles, and proxy capabilities accelerated. In 2011, Iran captured an American RQ-170 stealth reconnaissance drone reportedly brought down largely intact. Reverse engineering efforts accelerated indigenous UAV development, but the capture provided something equally valuable: insight into American reconnaissance patterns and surveillance methods. Understanding how carriers are tracked helps develop counter-surveillance and targeting networks. The 2019 Abqaiq attacks on Saudi oil facilities, widely attributed to Iran or Iranian-backed forces, showcased precision strike capabilities using drones and cruise missiles that evaded extensive air defenses. The strikes demonstrated that even sophisticated layered defensive systems could be penetrated through coordination, precise timing, and appropriate weapon selection, all directly applicable to defeating carrier group defenses. Throughout this period, China pursued parallel anti-access development in the Pacific, particularly the DF-21D and DF-26 anti-ship ballistic missiles, explicitly designed as carrier threats. Reported Sino-Iranian military cooperation provided Iran both validation and additional technical insights. Each experience reinforced an identical conclusion: carriers represent concentrated power but also concentrated vulnerability. Iran systematically built capabilities to exploit those vulnerabilities, creating layered defenses that force carriers to operate from distances that fundamentally diminish their effectiveness. This wasn't opportunistic weapons acquisition. It was coherent, multi-decade strategic evolution toward a singular objective, making American carrier operations in the Persian Gulf prohibitively risky. Understanding what Iran built explains the threat, but the real sophistication lies in how these systems work together to create impossible choices. To understand why Iran's anti-carrier strategy represents more than just regional military capability, we need to examine the specific operational mechanisms that create carrier vulnerability. This isn't about single weapon systems defeating defenses. It's about creating simultaneous dilemmas where every response involves unacceptable trade-offs. The first dilemma is geometric. Anti-ship ballistic missiles force carriers to operate beyond 300 kilometers from Iranian coastlines to remain outside engagement zones. But carrier-based F-18 Super Hornets have combat radii of approximately 400 nautical miles, roughly 740 kilometers, with standard loadouts. The mathematics become immediately problematic. Operating from safe distances means aircraft spend significant fuel simply reaching target areas, dramatically reducing loiter time, payload capacity, and sortie rates. More critically, it creates predictable flight paths. Aircraft must travel through known corridors to reach targets, making them vulnerable to integrated air defenses positioned along those routes. The carrier faces an impossible choice: operate closer and risk ship-killing missiles, or operate from safety and accept drastically reduced air-wing effectiveness. Distance doesn't eliminate risk, it transforms ship vulnerability into aircraft vulnerability, while simultaneously degrading the very capability carriers exist to provide. The second dilemma is arithmetic. A carrier strike group's defensive systems, Aegis radar, SM-2 and SM-6 missiles, phalanx, close-in weapons, electronic warfare suites represent extraordinary technological sophistication, but they possess finite magazine depth. The USS Gerald R. Ford carries approximately 90 aircraft, but only a limited number of defensive interceptors. Iran's swarm tactics, using hundreds of fast attack craft, each potentially carrying anti-ship missiles, create a magazine depth problem that no amount of technological advancement solves. Even with high kill rates, simultaneous attacks from multiple vectors can overwhelm defenses through simple mathematics. War game simulations consistently demonstrate that coordinated swarm attacks, especially when combined with missile salvos and mine threats, create scenarios where defensive systems exhaust interceptors before threats are neutralized. Iran doesn't need platforms matching American technological sophistication, they need sufficient numbers to exhaust sophisticated defenses. Quantity becomes its own quality when defensive magazines are finite. The third dilemma is complexity. Traditional carrier defenses were optimized for specific threat categories: aircraft, submarines, surface ships, or missiles. Iran's approach combines threats across domains simultaneously. Anti-ship ballistic missiles arrive on high-angle ballistic trajectories requiring SM-3 or SM-6 interceptors. Sea-skimming cruise missiles follow entirely different flight profiles, demanding different engagement geometries. Swarm boats require close-in weapons systems. Submarines and mines necessitate dedicated anti-submarine warfare assets. Drone surveillance feeding real-time targeting data requires electronic warfare and counter-drone capabilities. Each threat type demands different sensors, weapons, and tactical responses. Handling them individually is manageable. Handling them simultaneously creates coordination challenges and resource competition. Defending against one threat type often leaves vulnerabilities to others. The carrier strike group must simultaneously look up for ballistic missiles, scan horizontally for cruise missiles, and aircraft monitor surface contacts for swarm boats and search below for submarines, all while operating in potentially mined waters under persistent drone surveillance. No defensive system was designed for this level of multi-domain simultaneity. The fourth dilemma is geographic. The Persian Gulf's dimensions fundamentally favor defenders. Its narrow width, rarely exceeding 300 kilometers, means carriers have severely limited maneuvering space. Unlike open ocean operations where carriers can reposition across vast areas to complicate enemy targeting, Gulf operations create relatively predictable positioning. Iran's coastal positions provide interior lines. They can concentrate forces at threatened points faster than carriers can reposition to avoid them. The Strait of Hormuz becomes an operational choke point that transforms naval geometry. Any carrier entering or exiting must pass through a corridor just 21 miles wide, dominated by Iranian coastal positions, potential minefields, and overlapping engagement zones from multiple weapon systems. This creates temporal vulnerability windows where even brief exposure carries significant risk. Geography converts what would be temporary vulnerability in open ocean into sustained exposure in confined waters. The fifth dilemma may be the most strategically significant: inverted economics. A single carrier represents over $30 billion in construction costs and carries more than 5,000 personnel. The weapons threatening it exist on entirely different cost scales. A college far's anti-ship ballistic missile costs approximately $1 to $2 million. A fast attack craft perhaps $5 million. A naval mine between $25,000 and $100,000. Even accounting for low individual hit probabilities, the cost-exchange ratio favors Iran dramatically. They can afford to expend dozens of missiles and platforms if it results in carrier damage or destruction. The United States cannot afford to lose a carrier, not economically, not politically, not strategically. This asymmetry in acceptable losses creates operational caution that constrains carrier effectiveness even when no attack occurs. Risk avoidance becomes the governing logic and deterrent value erodes accordingly. These dilemmas don't operate independently, they combine and reinforce. The standoff problem increases aircraft vulnerability. Geographic constraints create predictable positioning that enables more effective swarm coordination. Multi-domain complexity strains the defensive systems that must counter swarm saturation and underlying everything. The cost exchange asymmetry makes every engagement calculation favor excessive caution. The result is an operational environment where carriers cannot fulfill their traditional role-assured power projection through forward presence. They can potentially survive in the Gulf with massive support defensive augmentation and severe operational constraints, but survival becomes the mission rather than enabling power projection. The deterrent value, the credible threat of intervention that carriers historically provided, erodes because adversaries recognize the constraints. Iran doesn't need to sink a carrier. They only need to make the operational environment sufficiently risky that carriers cannot effectively operate, and they've succeeded. But this isn't just about Iran creating military problems for carriers in the Persian Gulf. What makes this strategically critical is that this entire playbook is being adopted and expanded by peer competitors who possess far greater resources, and that's where everything changes. Iran's anti-carrier strategy might appear to be a regional problem confined to the Persian Gulf's unique geography, but that assessment misses the strategic reality. Iran has provided a template, and peer competitors with vastly greater resources are replicating it on scales that transform the entire calculus of American naval power. China has observed Iran's approach carefully and developed the world's most sophisticated anti-access or area denial network specifically designed to prevent carrier operations in the Western Pacific. The DF-21D and DF-26 anti-ship ballistic missiles provide engagement ranges exceeding 500 kilometers, forcing carriers to operate from distances that severely limit effectiveness in Taiwan Strait or South China Sea scenarios. China adds layers of capability Iran cannot match: long-range H-6 bombers carrying anti-ship cruise missiles, advanced submarine forces, extensive satellite surveillance networks providing persistent tracking and counter-space capabilities threatening the reconnaissance and communication systems carriers fundamentally depend upon. If Iran's regional capabilities create operational constraints, China's peer-level systems potentially render carriers unable to operate in Western Pacific contested environments at all. The implications extend far beyond naval tactics. Taiwan's security depends fundamentally on credible American intervention capability. If carriers cannot operate safely within effective range during a crisis, what becomes of deterrence credibility? The question isn't hypothetical, it's the central strategic dilemma facing Pacific security architecture. Russia similarly employs layered anti-access systems across multiple theaters. The Black Sea-Baltic region and Eastern Mediterranean all feature overlapping defenses: caliber cruise missiles launched from ships and submarines, Bastion coastal defense systems, advanced Kilo-class submarines, and integrated air defenses, creating environments where NATO carrier operations face significant constraints. While less technologically advanced than China's capabilities, Russian systems demonstrate that Iran's template is being globally replicated by any power seeking to offset American naval superiority. The strategy is no longer regional, it's becoming universal among potential adversaries. This replication creates cascading effects on American alliance structures. Security commitments to Japan, South Korea, the Philippines, Australia, and Taiwan all implicitly rely on carrier-based power projection as the rapid response guarantee. The credibility of extended deterrence depends on allies believing American military power can arrive quickly and operate effectively during crises. If allies perceive carriers as too vulnerable to operate in contested environments, confidence in American security guarantees begins eroding. Japan has already invested heavily in indigenous defense capabilities, partially hedging against doubts about American reliability. South Korea pursues similar paths. These aren't expressions of anti-American sentiment, they're rational responses to perceived gaps in American ability to fulfill commitments. The alliance architecture that has maintained regional stability for decades begins fragmenting when the military capability underpinning it faces fundamental questions about viability. The implications extend to force structure and resource allocation. The U.S. Navy currently operates 11 carrier strike groups at approximately $30 billion each for construction alone, plus billions annually in operating costs. If carriers cannot effectively operate in the most strategically critical environments, the Persian Gulf, Western Pacific, and contested European waters, this represents potentially catastrophic resource misallocation. The debate within Pentagon planning circles has intensified significantly. Should the Navy continue investing in vulnerable high-value platforms or fundamentally shift toward distributed systems unmanned platforms? Expanded submarine forces and long-range strike capabilities that don't create concentrated vulnerabilities. This isn't theoretical discussion. The force structure assessments conducted throughout the early 2020s explicitly grapple with these questions, and the answers will determine naval composition for decades. Perhaps most significantly, there's a deterrence psychology dimension that may matter more than actual military capabilities. Deterrence depends on adversary belief that aggression carries unacceptable costs. When Iran conducts swarm exercises near the Strait of Hormuz or China tests carrier-killer missiles in highly publicized exercises, they're not merely testing military capabilities, they're demonstrating to regional and global audiences that American carriers face operational constraints. This shapes adversary calculations about whether American intervention is sufficiently likely to deter aggression. Russia's invasion of Ukraine occurred partially because Moscow judged meaningful Western military response unlikely. Similar calculations could apply to Chinese scenarios regarding Taiwan if carrier intervention appears too risky. The perception of vulnerability may constrain American options as much as actual vulnerability. Finally, Iran has demonstrated that relatively inexpensive asymmetric systems can credibly threaten the most expensive military platforms ever created. This lesson is being studied by every nation facing potential U.S. military intervention: North Korea, Venezuela, and potentially even non-state actors with state sponsorship. The proliferation of precision-guided weapons, surveillance drones, and coordination technologies makes Iran's playbook increasingly accessible beyond traditional military powers. These implications raise an unavoidable question. If carriers face these systemic constraints, what actually happens next? Does the U.S. Navy adapt its operational concepts, double down on existing platforms, or fundamentally restructure how it projects power across contested environments? The strategic challenges carriers now face don't exist in isolation from potential solutions. Several pathways forward are emerging, each involving distinct trade-offs between capability, cost, and transformation timelines. The first scenario involves operational adaptation towards standoff warfare. The U.S. Navy accepts that carriers cannot operate in high-threat environments as they historically did and restructures operations accordingly. This means extending carrier air wing ranges through aerial refueling capabilities and long-range unmanned combat. Aerial vehicles: the MQ-25 Stingray refueling drone represents early steps in this direction. It involves developing longer-range carrier-based missiles and precision-guided munitions, allowing strikes from outside anti-access engagement zones, and it requires closer coordination with land-based air forces and submarine-launched cruise missiles for integrated operations, where carriers provide one component rather than the primary capability. The benefits are straightforward. This approach preserves existing carrier investments while acknowledging operational limitations. But the challenges are equally clear. Standoff operations significantly reduce carrier effectiveness compared to historical close proximity missions. The fundamental vulnerability problem isn't solved, it's merely managed through distance, and the approach requires extensive supporting capabilities that may not exist in all theaters. Despite these limitations, probability remains high. This adaptation is already occurring in doctrinal development and acquisition priorities across naval planning. The second scenario represents something far more fundamental: force structure revolution toward distributed systems. Rather than incrementally adapting carriers, the Navy fundamentally restructures away from carrier centricity toward fleets of smaller, more numerous platforms. This would mean significantly expanding attack submarine forces, which can operate covertly in contested environments carriers cannot. It involves deploying large numbers of unmanned surface and underwater vessels, creating distributed targeting problems for adversaries. Arsenal ships carrying hundreds of long-range missiles would provide concentrated firepower without concentrated vulnerability. Smaller light carriers or amphibious assault ships could operate in less contested environments, while main carrier forces remain outside threat zones. The strategic benefits appear compelling. Distributed systems eliminate concentrated vulnerabilities, create complex targeting dilemmas for adversaries, and may prove more cost-effective given modern weapons capabilities. But the challenges are massive. This requires complete doctrinal, organizational, and industrial-based transformation, a process requiring decades and hundreds of billions in transition costs. Congressional resistance to retiring existing carriers would be formidable. The diplomatic signaling power that large carriers provide would be lost. And serious questions remain about whether distributed systems can generate equivalent combat power to concentrated carrier strike groups. Probability over a 15 to 20-year timeline is moderate. Strategic thinking increasingly points in this direction, but institutional and political obstacles remain enormous. The third scenario pursues technological counter-revolution through advanced defenses. Rather than accepting vulnerability or restructuring forces, the Navy invests heavily in technologies designed to restore carrier survivability. Directed energy weapons lasers could engage swarm boats and drones at dramatically lower cost per shot than missiles, addressing magazine depth problems. Electromagnetic railguns would provide high-volume defensive fire. Advanced electronic warfare and cyber capabilities could disrupt adversary targeting networks before weapons launch. Hypersonic interceptors might engage anti-ship ballistic missiles during terminal phase, integrated. Space-based surveillance would provide early warning and persistent tracking. If successful, this approach restores carrier operational freedom without requiring wholesale force restructuring. But significant challenges remain. Many technologies are developmental with uncertain timelines. Even successful deployment may only temporarily restore advantage until adversaries develop countermeasures, and the fundamental cost exchange asymmetry persists. Defensive technologies remain expensive relative to the threats they counter. High investment in these areas appears likely, but success remains uncertain and timelines extended, fully solving the vulnerability problem within a 10-year horizon appears improbable. The fourth scenario involves strategic acceptance and role redefinition. The United States acknowledges that carriers will not operate in high-end contested environments against peer competitors, but retains them for different purposes: lower-intensity operations, presence missions in permissive environments, and humanitarian operations, where their mobility and self-sufficiency provide unique advantages. High-end conflict against China or Russia would rely primarily on submarines, long-range bombers, land-based missiles, and space and cyber capabilities. Carriers become secondary rather than primary instruments of power projection. This represents honest assessment of limitations and allows rational resource allocation. But it also represents fundamental departure from 70 years of naval strategy, ensuring enormous political and institutional resistance. It raises uncomfortable questions about alliance commitments built explicitly on carrier presence. Intentional adoption of this scenario appears unlikely, but it may occur by default if adaptation scenarios fail to restore meaningful carrier effectiveness. The most probable outcome involves some combination of the first and third scenarios: operational adaptation, emphasizing standoff capabilities while simultaneously investing in defensive technologies, with gradual drift toward more distributed systems over an extended timeline. No revolutionary transformation, but incremental evolution. Acknowledging carrier limitations while seeking technological solutions to restore capability. Whichever path the U.S. Navy ultimately chooses, the era of unchallenged carrier dominance has definitively ended. The question is whether America adapts quickly enough and whether the alternatives prove more effective than the platforms they're replacing. Iran hasn't defeated the U.S. Navy in any traditional sense. They haven't sunk carriers, won fleet engagements, or established naval superiority. What they've accomplished is perhaps more strategically significant. They've made the conditions under which carriers can effectively operate far more restrictive than at any point since World War II. This represents something deeper than regional military balance. It reveals how military technological evolution periodically renders previous dominance models obsolete or severely constrained. The historical pattern is clear. Battleships dominated naval warfare for decades until aircraft carriers made them vulnerable targets, too expensive to risk in contested environments. Carriers themselves may now be experiencing a similar transition, not to complete obsolescence, but to a substantially narrower operational envelope where their effectiveness depends on environmental conditions rather than representing assured dominance regardless of context. The deeper lesson transcends specific platforms. Military superiority increasingly depends not on possessing the most powerful systems, but on having capabilities that can actually be employed in operationally relevant environments. A carrier that cannot safely operate in contested waters is strategically irrelevant regardless of its technical sophistication or theoretical combat power. Iran understood this fundamental asymmetry and built accordingly, not attempting to match American platforms directly, but creating environments where those platforms cannot function effectively. This dynamic extends well beyond naval warfare. It applies to any concentrated, expensive military capability facing distributed, inexpensive countermeasures. The economics of precision-guided weapons, sensor networks, and autonomous systems increasingly favor defenders and asymmetric strategies over concentrated power projection platforms. The cost-exchange ratios that once favored technologically advanced powers are inverting. The question facing American strategists isn't whether carriers remain powerful; they absolutely do. It's whether that power can be translated into strategic effect in the environments where it matters most. Iran has demonstrated the answer in the Persian Gulf, at least, is increasingly doubtful. And if a regional power with limited resources can create this strategic reality, what happens when peer competitors with far greater capabilities apply the same principles across entire oceans? The carrier era isn't over, but the era of carriers guaranteeing control, the assumption shaping American strategy for 70 years, may be drawing to a close.